Okay, lesson 5, surface area of composite figures. So we're going to have to refer back to the previous lessons to figure out the formulas that we need, but we might not be able to just use the formulas as they're given. We might have to use parts of the formulas or figure out the whole thing and divide it by 2 or add different formulas together based on the shape. All right, so for example, this first one here is it's a basic cylinder. So determine the amount of paper required to make the label of the can. Well, do you have a label on the top or the bottom? No, it's just aluminum. So the formula for the surface area of an entire cylinder is 2 pi r squared plus 2 pi rh. And this is the top and bottom. And this is the lateral area, or the label part of it. Well, we don't need to use the entire formula. We can scratch out that part because we do not need the top and the bottom. What we do need is the lateral area because that's where the actual label is. So the surface area is 2 times pi times the radius, which we need to figure out. So the diameter is 6.6, that means the radius is 3.3, and the height is 12.1. So 2 times pi times 3.3 times 12.1, we get 250.9 centimeters squared. All right. Here we have a hemisphere, so a half of a circle. So it's produced by cutting a sphere with a plane through the center. What is the surface area of the outside of this hemisphere if the radius is 80 centimeters squared? So we have to use a couple different things, all right? The surface area of a sphere is 4 pi r squared, but we don't need the whole thing, we just need half of it. So let's do all of that and then divide it by 2. That's going to give us like the outer shell. All right. And then we need to do this circle here. All right. So that circle is just pi r squared. All right. So let's calculate these. In this case, what is the radius? Okay, so the radius is 80. So we're going to do 4 times pi times 80 squared. And that gives us a pretty big number. So 4 times pi times 80 squared. We need to divide that by 2 because we just need half of it. So that's 40,212.38. And then the surface area of the bottom is pi r squared, so pi times 80 squared. And if we add that back to 40,212.38, you get a total of 60,318.6 centimeters squared. All right. Determine the amount of cardboard required to make this box without a top. Okay, so we have the front and back that are going to be the same. We have the sides, which are the same, but then we have the bottom, which is all by its lonesome. All right, so the front and back, there are no measurements in this example, so let's come up with some measurements. So 15, 5, and 3. Okay, so let's do the front and back would be 15 by 3. And then we have 2 of those, so we'll multiply that by 2. The sides are going to be 3 by 5. And we have 2 of those, so we multiply by 2. And then the bottom is 15 by 5, and we just have 1 of those, so we don't have to multiply by 2. So 15 times 3 times 2 equals 90. 3 times 5 times 2, that gives us 30. And then 15 times 5 is 75 centimeters squared. So the total, if we add all those up, 75 plus 30 plus 90 gives us 195 centimeters squared. All right, so composite objects, it gets a little tricky as to what you actually need and what you don't need. Okay, now composite objects are created using two more objects. Follow the general rule. The surface area is the surface area of each object minus 2 of the overlapped area. And why it's 2 times the overlapped area is because it affects both shapes. Okay, so this here, if we were to kind of highlight that part there, that's the overlapped shape. All right, so we'll figure that out later. But what we do need to do is figure out the surface area of each shape. All right, so shape number 1, the warehouse, and shape number 2, the loading dock. And we go back to our formulas way back when. It's going to be the 2 times the length times the width plus 2 times the width times height plus 2 times the length times height. All right, for each thing. So let's do the warehouse. So the warehouse has a length of 30, a height of 20, and a width of 20. All right, so 2 times length times width plus 2 times width and height plus 2 times length times height. Okay. So the warehouse, let's calculate this all out. 2 times 30 times 20 plus 2 times 20 times 20 plus 2 times 30 times 20. So the warehouse looks to be 3,200 meters squared. And the loading dock has a length of 30, a width of 20, and a height of 10. So let's use the same formula. So 2 times length times width plus 2 times width times height plus 2 times length times height. So the loading dock comes out to be 2,200. Okay, so we kind of have everything so far. Then we need to figure out the overlap. So the overlap is going to be the same as this front face. Okay, so it's going to be 20 times 10. And then because these two shapes meet together, we need to multiply that by 2. So the overlap is 20 times 10 times 2. That gives us 400 meters squared. So the total, we're going to take 3,200, we're going to add it to 2,200, but then subtract 400 because that is not exposed. So 3,200 plus 2,200 minus 400 gives us a total exposed area. Oops, I need an extra 0 in there. Is 5,000 meters squared. Okay. Last example in this lesson. A company contracts to build a silo as shown in the diagram to the right. The silo will have a base and a hemisphere will form the roof of the silo. Calculate the amount of material required to build a silo. All right, so we're not really talking about the barn, so we can forget about that part. It's just this part. So we have a hemisphere, okay, so half of a circle, and then we have the lateral area of a cylinder, okay, so not including the top and the bottom, just that part, okay? Those are pretty poor diagrams, so I'm just going to erase them. So the first, the hemisphere, the surface area of a sphere is 4 pi r squared, but we only need half of it, so let's divide that by 2. And then the surface area of a cylinder is 2 pi r squared plus 2 pi rh, but we don't need this part because that's the 2 circles in the cylinder. We just need that part. Okay, so let's do this. So 4 times pi, and what's the radius? The radius is 1.2 meters. Okay, so 4 times pi times 1.2 squared. All right, and then we need to divide that whole thing by 2. So for that, we get, let's try that again, 4 times pi times 1.2 squared. That gives us 18. And we need to divide by 2. Yep, so I had it right. So that's 9.05 meters squared. And then this part, 2 times pi times radius is 1.2 times the height of 9 meters. That comes out to be 67.85 meters. So let's add that back to 9.05. So our total, 76.9 meters squared.